delighted to be here today to talk with you about the Connect Research Center. My name is Dan Kilper. I'm the director of the center and professor at Trinity College Dublin. So Connect is located at the historic Dunlop Oriel House in Trinity College Dublin, right in the heart of Dublin itself. And we're made up of 10 institutes of higher education and one of Europe's most prestigious research centers in future networks and communications. We have over 16 principal investigators and 250 researchers in the center. So it's a very large center. Our vision at Connect is a future of sustainably deployed, dependable networks that foster innovation in services and customer experience, empower citizens, and improve quality of life. So within Connect, we've built up an ecosystem of industry partners that we work with very closely. This includes 24 multinationals, 16 SMEs, and 4 local government authorities. One of the ways that we like to work with our industry partners is on European projects. So we've coordinated over 10 European projects and participated on 47 projects. And this has amounted to over 21 million in European project funding. So with this ecosystem of industry and academic partners, we've been able to perform really groundbreaking research. And here I'd like to highlight a few of those areas that I feel that the Connect Center is especially known for and have been important contributions. So we've been pioneering research on open shared radios and radio access networks. So this includes software-defined radios, full duplex, spectrum and resource sharing, and multi-tenant PONs. In addition to that, at the chip level, we've been looking at innovative, low-power, energy-efficient hardware and Internet of Things technologies, or IoT. So this includes MEMS energy harvesting devices, high-efficiency batteries, and liquid cooling. We're also uniquely known for our transdisciplinary research. We're bringing the creative arts into STEM research to create STEAM research, and also doing novel work on bio-nano networks. But perhaps what we're most well known for is our real-world smart technology testbeds at the heart of the world-leading smart docklands, and importantly, extending across all of Ireland. So this includes our Pervasive Nation testbed, our new Open Ireland testbed, Cork Smart Gateway, and a host of other testbeds and resources around the country. So let's talk about some of these technologies that we work on and what's happening today. So sustainable IoT is particularly important. People are talking about powering smart things for the 1 trillion sensor economy. How do we get there? That's a big challenge. But we've been looking at these smart systems in a number of application spaces, such as precision agriculture, environmental monitoring, robotics. And then we're developing sensors like biochemical and physical sensors, flexible and wearable sensors, as well as molecular and DNA technologies. And importantly, we need to understand how we can power these sustainably. So within the Connect Center, we're developing new micro energy generators that can be part of these devices that we'll find everywhere, this 1 trillion sensors, micro batteries, supercapacitors, and fuel cells, power management ICs, and integrated magnetics. So we're working at the nanoscale to bring sustainable, energy efficient solutions into this IoT space. And we do this by bringing a large ecosystem of different university partners within our center, led by Tyndall National Institute. So moving up to the network element level. So we take these devices and we can put them together with technologies such as looking at new radios that can be used for millimeter wave technology. So you've probably heard about millimeter wave as a big new source of spectrum for our mobile networks. And one of the ways that we see to deliver this is with something called massive MIMO, which is large arrays of antennas that allow you to then form beams at these millimeter wave frequencies to get that very high bandwidth to each end users. And at UCD, we have a team that's worked on a technology where they can do over-the-air characterization of this system, and especially these power amplifiers that are driving each one of those antennas. They're able to characterize the power amplifiers reconstruct their outputs, and then construct digital pre-distortion that can effectively linearize each of the channels in this interface. So this allows for a full angle, so all the different angles of reaching the users from these antennas, a digital pre-distortion. This work was done with Xilinx and Analog Devices, and it's been an award-winning technology. Moving up to systems and network levels. So shared networks are extremely important today. So people are talking about new business models. How can we get more value out of the network infrastructure that's there? And one of the ways is through neutral hosts and sharing. And especially when you get to the access point and you're trying to reach the users in those end applications. So fiber to the home or fiber to the curb is an area where we need more sharing capabilities. Well, within the Connect Center, we pioneered the virtualization of passive optical networks, which are these fiber networks in the access space. And we use a virtual dynamic bandwidth allocation technology to do this. We filed patents on it, and we're influencing the standards for the next generation technologies. This is opening up multi-tenant access networks. At the same time, in shared networks, we need to make use of data centers and heavy use of data centers. And that's often constrained by thermal limits. And so we've innovated in terms of sustainable electronic cooling techniques. And we're spinning out a company called Nexalis to basically bring this technology to market. Okay, so we've heard a lot about autonomous vehicles and smart driving cars, connected vehicles. So we're doing work in this space. How do the networks connect to those vehicles? So the next big thing, and to make these smart vehicles more reliable, is to use the infrastructure, use the network around them. So within Connect, we've released the only connected vehicle to X, so vehicle to infrastructure, full stack, open source, release 14 side link model. And that's being used by universities and companies around the world. And we've been looking at then smart intersections. So how do the vehicles talk to the infrastructure within these intersections and understand that physical layer in terms of forming networks between these vehicles. Shown on the right here, you can imagine that if vehicles are trying to talk to each other, what happens when a bus or some other big vehicle shadows the vehicle-to-vehicle communication. So we've exploring techniques around that, as well as smart scheduling for taking advantage of when you have a strong link to send that data through. So these are some examples that we've been working on in this space. Going back to millimeter wave, there's a big challenge in getting the high capacity and the high speeds of millimeter wave to moving platforms over long distances. And by moving platforms, I mean a cruise ship or a helicopter. So how do we get gigabits per second connectivity to these moving platforms? There's challenges around aligning these millimeter wave beams. There's sensitivity to vibrations because it's generally a beam forming type technology. We've had a breakthrough and showed a proof of concept prototype, both connecting to in the air to a helicopter and a cruise ship. This is work done with our Maynooth team. We were able to achieve gigabits per second to a helicopter at 16 kilometers, the ship at 26 kilometers out. So you probably heard a lot about AI and machine learning. It's very important for networks today. It's a great way to optimize networks to again, get more value out of them. So in Connect, we have a number of groups working on AI techniques in the network space. This is some work from the group at Waterford Technology, where you might have heard of virtual network functions. So where do you put your virtual network functions? How do you know where the demand is? How can you scale up these virtual capabilities? So they looked at different techniques in using graph neural networks to enhance that capability, improve quality of service for dense wireless LAN deployments. So how do we do this groundbreaking technology? Well, it starts again with the devices. So we have facilities that allow us to design the ICs, microelectronics, look at new materials, create 5G and IoT devices and then characterize them, for example, in our radio space test bed. And so these state-of-the-art facilities for working with the devices allows us to do game-changing new technologies to bring those into the network and really make a difference. At the same time, we're looking at that application level and how do we move these technologies into the new spaces. So Telecom Infra Project is one that's being driven by industry, and it's an international initiative. And we're participating in the Open Optical and Packet group, as well as the Open RAN group in TIP. But importantly, we got together with Dublin City Council and we created a new working group, the Connected City Infrastructure Working Group. And this is really looking at the challenges that cities face in making infrastructure available and providing that value and getting the technologies out to the users and to these smart city applications. So overcoming those barriers that you find at the city level, we're right in there working on new innovations in this space. One of the ways that we do this is we're able to inform this type of activity through real world test beds. So many of you might have heard of our Pervasive Nation test bed across all of Ireland that allows you to connect the Internet of Things, so many small sensors and devices to the network. And that's allowed us to do some fantastic research. Well, now we're adding to that what we call Open Ireland, which this is really an advanced, high-speed, high-performance type of test bed. It's situated in the Smart Docklands area, connecting between Trinity College and DCU. And it involves many open platforms that are very high performance. So dark fiber type networks with white boxes, as well as open radio interfaces to allow us to do much more. And so we bring this together and look at these new higher performance advanced applications. So AI-driven technologies, that network customization at very high speed, so we can support, say, VR and AR type applications, extended reality, cloud robotics, connected vehicles, and e-health. Many of those applications I was just talking about, how do we make those work in the real world? Open Ireland is a platform that's going to allow us to investigate that. And the idea is that we can get that real world environment involved here. So for example, this is some characterization of the spectrum and what kind of performance you can get through the city, dealing with the complexities of that actual environment. And our test beds furthermore connect around the world and are having global impact. So we're working closely with the Cosmos test bed in New York City, which is another smart city wireless focused test bed, as well as connecting into Europe, where there's if you've heard of P4 technology, so there's a large test bed initiative around that we're connected into and we're a part of. And so this really gives us a great starting point for looking at the next generation of millimeter wave and terahertz technologies and doing experimentation on that, looking at connected city infrastructure. And even with this dark fiber infrastructure, we're able to look at quantum internet technology. So it's really exciting. And so we have this collection of test beds, from characterizing devices to large scale network test beds to smart city environments, that really allows us to do substantial research and innovation across Connect. Our Connect themes are around where technologies are going today. And in the network, we see dependable networks being a really important dimension. So this is mission critical type networks, ultra low latency communications. I've mentioned sustainable IoT. So that's an important direction going forward. Link performance, how do we get those higher performance and gigabits per second out of a wireless network using millimeter wave and terahertz technologies. Today, we're customizing networks in ways that we could never do before with virtual network functions, software-defined radios. We're looking at AI approaches with data-driven optimization and management. And all of this opens up new business models. And we have an entire research effort around understanding those new business models with the new operators approach. So importantly, cutting across all of these different dimensions of networks that we're exploring for future networks is what we call our Enable project. So this is a project that basically we work with other SFI centers. So We bring in Insight, which is looking at data analytics, as well as Lyra, which is a software research center. So we bring in the data analytics and the software together with our networks to explore these smart city applications. And that allows us to really get at the application space, the software space, and see how our hardware is able to work in that environment. And so here we're talking about bringing all these different types of smart networks with sensors in buildings, pollution monitors, mobility monitors. We gather data and we can explore this full cycle of gathering the data, analyzing it, actuating, and then getting citizen feedback on what's happening with those applications. And this has opened up many different activities and research for us together with industry partners, as well as, for example, Dublin City Council in the Smart Docklands area, working on information-centric networking for vehicles, ride-sharing type applications, smart building and mobility, looking at passenger flow in airports. So there's a whole host of different applications that we've been able to explore through this Enable project. And of course, in the news, you've heard about the importance of cybersecurity, and boy, there's never been a time when this has been more important. We actually have brought in to Connect 2 new researchers who are working in the cybersecurity space, really world-leading experts in that space. They're heading up a working group that is building cybersecurity into all of our research across the different themes that I mentioned. So sustainable IoT, how do you have secure authentication methods? How do you handle malicious actors? What about security and privacy? Customized networks, so this virtualized functions and SDN, how do you secure that? How do you deal with trust and accountability in these open systems? So that's across everything that we do. We're looking at cybersecurity and can work with our industry partners in this space. Importantly, though, we're always keeping track of what are the hot new topics, where's new innovation coming, and taking a leadership role in this. One of the areas that is really beginning to take off is quantum computing technologies. And as we develop these quantum computers, everyone now is thinking about how do we network those. So people are talking about a quantum internet that's going to connect computers as well as quantum sensors to be able to do things that we've never been able to do because of their unique capabilities. This is going beyond security. This is talking about really using quantum in new ways. In the wireless space, you might have heard about these intelligent reflective surfaces, but we're adding sensing into those surfaces and looking at that. Looking at immersive and reliable AR and VR over networks, wireless optical communications, another way to get high bandwidth to the end user, new cryogenic CMOS technologies for use in satellite and quantum applications, as well as new types of SOCs for neural networks, looking at mixed signal, not just digital. And I mentioned before the bio nano systems and networks. So in general, when you think about networks, we want you to think Connect. We're doing just about everything that there is in terms of research related to networks that's right at the cutting edge and really having impact. Not only that, we're educating the workforce for this next generation network. So over the life of Connect, we've educated 129 PhD graduates and 62 master's students. Many of those are staying in Ireland, and they're working with our industry partners. So if you're struggling to figure out how to stretch your euros farther, get research insights, looking to test your technologies in real world test beds, find qualified graduates and the workforce in this space, well, Connect is the answer for you there. So we're developing reports, publications, prototypes, simulations. We've got our real world test beds. We have an incredible ecosystem across the 10 universities of over 250 researchers working in this space, and students and postdocs being educated in this space. But importantly, I want to point you to this 12 million euro in matching funds for research collaboration with industry. So the Connect Center, we just got our mandate from Science Foundation Ireland renewed for another 6 years. And what that really means is that we've got basically a new budget, and we've got a new 12 million euro of funding from Science Foundation Ireland to use to match industry funding on projects. So that's 12 million on the table for industry partners to take advantage of. And unlike in the past, where often the companies were signing up before a center like this would start, and that money spent in advance, in this case, we've got that money sitting on the table today and enabling us to work with industry partners and to get more value out of the research and innovation that they do with us. So with that, I'd like to thank you and hand it back to Pat for any questions that you might have.